page 614, doing 1 through 29. Odds right now. Number 1 says find the 3 basic trig ratios for each acute angle of each right triangle below. You guys think you know what they mean?
No.
Maybe?
Okay. Sine of A,
Yeah.
Oh.
cosine of A,
So.
tangent of A, what else?
We have to do all
Sine,
sides,
cos,
cosine,
and tangent.
Okay, this is not gonna be that hard.
We have to do
It's kind of like what we did yesterday on the worksheet. Those are the A and B are the 2 acute angles. So on number 1, what do you guys think we should do first? Okay, the correct answer is find the hypotenuse.
yeah.
So- How do we find the hypotenuse on number 1? Pythagorean theorem. 10 squared plus 7 squared. What's 10 squared plus 7 squared?
149.
Yeah,
149. Does 149 simplify?
No.
No.
Probably not.
No.
It's a big enough number that I'm not 100% sure, but I'm probably about 90% sure. You just plugged it in, it didn't work. Okay, so we're just gonna leave. This is the hypotenuse, so we'll have to use that. So, okay. All right, we'll start right here. Sine of A. So if you don't have this memorized, you might want to write SOHCAHTOA on the top of your page and all that stuff. So sine equals what over what?
Opposite over hypotenuse.
What's the opposite of angle A?
7.
What's the hypotenuse?
Whatever that is.
This thing. Okay, how do we do 7 over square root of 149? You just multiply by square root of 1. That's so weird that they chose those numbers. Multiply by square root of 149 and you get this. So anyway, that should be right here, I guess. Yeah. There's kind of a trick for the B's though. You guys probably forgot. Cosine of A. Cosine is what over what? Adjacent of A is 10. Hypotenuse is
That
square root of 149. So if you multiply by square root of 149, you'll get 10 square root of 149 over 149. Tangent of A. Tangent is opposite over adjacent. What's the opposite of angle A? 7. What's the adjacent? Can I do anything with that? No. Doesn't reduce. You should reduce it, right, Josie?
Yep.
All right. There's kind of a way we could cheat on these. Do you guys remember how?
Yeah, they like
Sine of
split.
B is
All of them have a
cosine
partner.
of A.
Right. Sine of B is going to be cosine of A. Because when you switch the A and B, the opposite and adjacent switch. So it just, yeah. So we could go through it, but we already did our practice. That's good enough. So yeah, these two switch, and these two switch.
And then you flip the tangent, like
Yes.
7 over 10 or 7.
Yeah, and when you switch the angles, the opposite and adjacent switch, so the tangent flips upside down. So yeah, it's 10 over 7. Is the hypotenuse on number 2 going to be 4?
No.
No. Okay, 3, 4, 5 is a right triangle, but 5 would have to be the hypotenuse. So you do 3 squared plus 5 squared. 9 plus 25 is 34. Square root of 34.
9 times 7. No, that's 36.
34. 9 plus 20. It's just going to be square root of 34. That's what I'm saying. Number 3. Find the other two trig ratios for angle A if cosine of A is 7 squared 193 over 193. Kind of like our answers we just had. So we kind of did some of this yesterday. If this is angle A, let's see, 7. Okay, that was cosine of the angle. So cosine gives us what now? Adjacent hypotenuse. What's adjacent to angle A in my picture? Bottom. What's the hypotenuse? Top left. And what are we supposed to find?
AC.
Find the other two. Okay, we're supposed to find sine and tangent. Sine of A and tangent of A. So guess what I need to do first?
Find that.
I'm gonna need the opposite, yeah. So what could I plug in my calculator to get this?
193 squared minus 7.
There you go. 193 squared minus this squared. Would that give us the answer? A squared minus, or A squared plus B squared equals C squared. So C squared minus B squared equals A squared. What we want is A. So in other words, you have to take the square root. This would give us the square of the answer, so we have to take the square root. Let me tell me what you got when you got it.
12 squared 193.
Yeah, this doesn't mean this is the actual length of the sides, it just means it's the ratio of the length of the sides, which that's all we need anyway, so it's okay. Okay, sine of A is what over what? Sine is opposite hypotenuse. So 12 squared root of 193, yuck, over 190. Maybe I should have talked about it the other way. Anyway, opposite over hypotenuse. They chose some messy numbers. They could have been nice, but okay, and then we need tangent. Tangent is what over what? Opposite over adjacent. What happens when I put square root of 193 over square root of 193? Cancels out. So really it's just going to be 12 over 7, what we need. So just that stuff. Three was kind of a doozy, but there's not a 4 to go with it, so you guys kind of got out of it. Number 5, 6, 4 through 7, 45, 45, 90. You guys remember those? Let's put those up here. I think we did a worksheet review on Monday, thankfully. Do you guys remember the ratio? Let's start with the 45, 45, 90.
1, 1, and then the square root.
Good. And we do need to have these memorized. Sorry. This is like, sometimes these problems you can solve with like the Pythagorean theorem, but it's a lot of work. So you don't necessarily need them all the time. But like these problems are some of the things that'll be like guaranteed to be on the ACT. So, and if you know these ratios, then you can solve it quick. If you don't know the ratios, then you take a while. Okay, the other one was a 60, 30, 90. And let's start with the short leg. What did I usually put down here? 1. The hypotenuse? 2 and square root of 3. Yeah, it can't be 3 because that would actually be bigger than hypotenuse, which is not possible. Alright, now what's numbers 5 say? AB is 12, so if you look in your picture, that's the hypotenuse on 45, 90. So does it just say find the other 2 legs, right? Find the other 2 sides. Yeah, okay. Okay, so how do I move from hypotenuse to leg on a 45, 45, 90? If I'm moving from leg to hypotenuse, what do? Times square root of 2. So if I'm going backwards, it's divided by square root of 2. How do we do 12 divided by square root of 2? Well, either have a Casio and just plug that in, like division, or you get rid of the square root of 2 on the bottom by doing that. So it's 12 square root of 2 over 2, which reduces to 6 square root of 2. First answer for number 5. I guess that would be the AC, I guess. AC is 6 square root of 2. What would the other leg have to be then? Same thing. So BC or CB or whatever is also 6 square root of 2. Okay, 7. 7 tricky. MN is 26. MN is the hypotenuse on the 30, 60, 90. Okay, so if the hypotenuse is 26, what is the short leg going to be? 13. Yeah, it's going to be half divided by 2. If the short leg is 13, what's the long leg going to be? 13 square root of 2. So I guess we'll write it down. NO is 13. And MO, long leg, is 13 square root of 2. Okay, they, on number 9, tangent of 45, it's basically calculator work. You could kind of cheat on 9, and, well, not cheat, you could use this opposite over Jason. But you can just use your calculator. I'll pause for a minute and I'll let you guys plug those in.
Is that order?
Huh?
Is that order? I'm just
Yeah. On 8, they actually did just do the decimal. Let's round to 4 I guess they did the first 4 digits. I wish they wouldn't have done that. Yeah, let's go to 4 decimal places, that's fine. Like the windshield cleaner. Like it's a mess. I think I might just trash that. Got kind of a lot of stuff to memorize this chapter, don't we? SOHCAHTOA, cosecant, secant, cotangent, special triangles. Is that all?
And special
Maybe I'll make this like number 2 on the test, and then if you get it wrong, I'll fix it, and you can use it on other current. Maybe, if I don't know, that might not work. All right, on 14, 15, 16, actually that's kind of calculator work too. How do we go backwards and find the angle for 14? Did you guys do these already?
The inverses.
Yes. To go backwards to find the angle, you just do sine inverse or cosine inverse. Usually we used ratios, but the decimals are the same thing. So number 14, just do sine inverse at 0.7314. And the book rounded it to the nearest degree. I'm guessing it comes pretty close to a degree already.
Sounds good.
That had to be Caleb, but still.
Do you want to get this to, the, not, decimal? Or am I gonna have to drop in the Cassius?
Wait, what's wrong?
It always comes out as a, decimal.
Oh, yeah, supposed to. Oh, Texas, on that, Texas Instruments don't do that. What are you
To
trying?
get a number to a fraction, then you just have to.
Not well, she's doing square roots. What are you looking at?
4 and 6. Both of them.
9 times square root of 2 is just 9 square root of 2.
Really?
Yeah. Alright, and then number 17 is just solving the rest of the triangle. So there's 3 blanks on the triangle. We gotta find the rest of the blanks. So it's 18, 27. Oh, there's. So I'll call this C, I guess. And we got a couple angles here that we gotta find. How could I find C? Start with that one. Pythagorean theorem. 18 squared plus 27 squared equals C squared. So after you do 18 squared plus 27 squared, you have to do the square root. So it's kind of a big number. It's a very big number. What does that come out to? It's a tough one. Comes out to square root of 1053. I wouldn't put this one on the test, it's too much. You could 1 plus 5 plus 3 is 9, so I know that 9 goes into this. So if you do 1053 divided by 9, it's 1, 1,
It's 117.
7. And then 1 plus 1 plus 7 is 9, so 9 goes into this.
16.
Let's see, 1, 3. So it's going to be 9 squared root of 13. I wouldn't do that to you guys, it's too much. Casios can do that automatically, so we could share the Casios, I guess, if we had to. Anyway, that's the first answer. C is 9 squared root of 13. Okay, so I'll call this angle A down here. How could I find angle A? Because angle B. Okay, relative relative to angle A, what's this side called?
Opposite.
And what trig function is opposite adjacent? Tangent. So that means tangent of angle A equals opposite over adjacent. So how do I find angle A here? Tangent inverse of 1826. Anytime you're doing a trig to find an angle, you're going to be using the inverse functions. And I guess we're still doing 4 decimal places. No, never mind, this is an angle. They rounded to the nearest degree, so what'd you guys get for that one? Should round up to 34. Okay, we could do something similar for angle B, but there's an easier way. Yeah, these 3 angles should add up to 180, right? And if you take out the 90-degree angle, these 2 angles should add up to 90. So if you just do 90 minus 34, yeah, you do get 56. And voila, we have solved the triangle. Okay, 19 and 20, we didn't actually do those. 22 through 24 we did. 21 through 24 we did. Yeah, should we try 19? No, probably shouldn't. You guys, we'll say that for a couple of years from now. Okay, so we're skipping 19 and 20. And doing 21, the word problem, your guys' favorite. Why don't you, no, they drew the picture for it. I was going to say, why don't you guys try and draw the picture instead of that, but you actually, since they did draw the picture, you don't even need all the words. They kind of ruined their own problem. Okay, anyways, you guys see the picture down there? Let's see what the problem says. Meteorologists can find the height of a cloud by shining a light vertically and then finding the angle of elevation to the spot where the light meets the clouds. Find the height of the cloud selected by the information given this. This might be how their machines work. They don't actually go out with a flashlight and do anything, but this might be how they set up the machines to figure it out. All right, 78 degrees and 800 feet. All right, how could I find x? Relative to 78 degrees, what 2 sides are we working with?
Opposite adjacent.
Which trig function uses opposite adjacent? Tangent. So it's tangent of 78 degrees should equal opposite over adjacent. And how do I solve that? Tangent of 78 times 800. Correct. They rounded to the 10th place on this one. First decimal place. Okay, on 22, the reciprocal identities. You guys remember those? So secant, do you guys remember what secant was the opposite of? Cosine, right. Cosecant was the opposite of sine, and secant was the opposite of cosine. It's the one where it seemed like cosecant should go with cosine, but it doesn't. So what they wanted on 22, I know this isn't even, but I'm gonna do it anyway. 22, you just put secant of x equals, you guys know what I'm gonna write? Doesn't equal cosine, equals 1 over cosine. So that's all they want for those. So I'll let you guys do 23 and 24. That's another thing we need to have memorized. Secant is reciprocal of cosine, cosecant is reciprocal of sine, cotangent, tangent. What? Oh, yeah. Alright, on 25, it says all the isosceles right triangles shown. What is an isosceles triangle?
Two sides.
Two sides are the same. So do you guys see what picture they're talking about?
Yes.
The triangle ABC with the x and the x. X and x means those two sides are the same. If those two sides are the same,
They're 45.
it must be this triangle, a 45, 45, 90. It has to be. Okay, so basically it's another special triangles problem. Okay, it doesn't give us any numbers, which means our answers are going to be in terms of x. So, first off, we can say what these angles are. They call the angles A and B. So, what's angle A going to be? I'll call it A. 45. So I'm just going to put angle A, I just put measure equals angle B equals 45 degrees. Okay. How about the hypotenuse though? That's the other thing we're missing.
X squared
Right. It's just times square root of 2. So it'll be x times the square root of 2. So I'll call the hypotenuse AB equals x squared root of 2. X times square root of 2. This is number 20. Okay, and 27, give the three basic trig ratios for angle A in the same triangle. So if you look at the other triangle that they're using that for 26 and 28, it's a 30, 60, 90, right? So anyway, but on 28, we're using the same triangle. Angle A is actually supposed to be this top angle up here, I guess, but it doesn't, not that it matters, they're the same thing. Okay, so squeeze it over here. Let's start with sine, I guess. Relative to angle A up here, what would sine of angle A be? Sine is what over what?
That'd be x over square root of 2.
Sine would be opposite over hypotenuse, so x over x squared root of 2. Actually, instead of using this, it might be easier to use this, because the ratios are the same. What happens on this though is the x's would cancel out, so you have 1 over square root of 2, but you can't leave the square root in the denominator. So it's going to be square root of 2 over 2. And okay, now cosine of A. So what's adjacent to A? X. What's hypotenuse? So it's the exact, because they're the same on both these sides, it's the same thing. So it's going to eventually get to square root of 2 over 2. And then what is the tangent of angle A? Yeah, opposite over adjacent. X over X, or 1. Okay, last one. I don't know if this will confuse us or not. It says if triangle ABC, what does that little symbol mean right there?
Similar.
Similar. What does similar mean?
Same shape.
Same shape. Are they the same size? Maybe, maybe not. Okay. And then they draw a picture for us down below. Just, I don't know, give us a visual. It says cosine of angle B is equal to 0.3657. See angle B in the left triangle. And then it says, what is cosine of angle E? Angle E is in the right triangle. Any ideas? Okay, if two triangles are similar, then the ratios of their sides are going to be the same. You guys remember that from the similar chapter?
Yeah.
And what cosine gives us is the ratio of two of the sides, the adjacent and the hypotenuse. But since B and E are like the same angle, the corresponding angles, their cosines are going to be the same. It's going to be the same ratio. That doesn't mean the lengths of the sides is the same. It just means the ratios of the sides is the same. So maybe on the big triangle it's like 4 and 2, and on the little triangle it's 2 and 1. Doesn't really matter. Whatever cosine of B is on the big triangle, that's going to be the same as cosine of E on a little triangle. Same ratios, so it's just 0.3657. Kind of a weird question. Out of the box thinking a little bit. All right, so you guys probably done half the evens already, but go ahead and try those evens. How far are you guys?
I'm done.
You're done? All right.